Hello and welcome. Today we're going to do something that's actually really cool. We're taking a bunch of brand new, totally blank network devices, and we're going to bring them to life, step by step. We are literally building a network from the ground up. So, have you ever pulled a new router or a switch out of the box and just thought, okay, now what? How does this thing go from being just a piece of hardware to a smart, functioning part of a network? Well, that's the exact mystery we're going to solve today. So this is where we begin. We've got devices with nothing but their factory settings. Our mission, and we are definitely choosing to accept it, is to get in there, configure them, connect them, and forge a working, breathing local network. All right, let's take a look at our playground. We've got one router, we'll call him R1, a couple of switches, SW1 and SW2, and 4 PCs. All of these guys are going to live together in one single local area network, or LAN. It's a pretty simple setup, but it's absolutely perfect for nailing down the fundamentals. And here is our game plan, our blueprint for making this happen. We're going to knock out 6 core tasks. We're going to give our devices names, assign them addresses, fine-tune how they talk to each other, label everything so we know what's what, lock down the ports we aren't using, and then, the most important part, we're going to save all our hard work. Okay, let's dive right in. First things first, every device needs a name. The default is just router, which, isn't super helpful when you have more than one. So let's start by giving our main router its own unique identity, R1. And check that out. With just one simple command, hostname R1, the change is instant. The prompt itself switches from router to R1. I know it seems like a small thing, but trust me, it's so important for knowing exactly which device you're configuring. Now, for maybe the most critical part of a device's identity, its address. An IP address is basically its home address on the network. Without it, data would have no idea where to go. And that subnet mask you see, think of that as the zip code. It tells the data which neighborhood or which network that address belongs to. And this is the magic command right here. We go into the router's main interface, we type IP address, and then we give it the specific address and its subnet mask. This one line officially puts our router on the map of our brand new network. Now this is a fantastic pro tip from the source material. Normally, if you're in configuration mode, you have to back out to run commands to check your work. But if you just stick the word do in front of your command, you can run it from anywhere. It is a massive time saver, for real. Okay, so our devices have names, they have addresses. Awesome. Next up, we need to fine-tune the actual physical links connecting them. We're going to focus on speed, making sure everything is labeled clearly, and a little bit of basic security. So look, most modern devices can figure this stuff out on their own, but it's always a best practice to manually set the speed and duplex on your main connections. It just prevents weird errors and gives you a rock-solid link. So here, we're locking the speed at 1 gigabit per second, and we're setting the duplex to full, which just means data can be sent and received at the very same time. It's like turning a 1-lane road into a 2-lane highway. And this command right here illustrates one of the best habits you can ever get into. The description command is like putting a little label on a cable. Seriously, 6 months from now, when you're trying to figure out what connects to what, you will be so happy you took 10 seconds to do this. So an interface is pretty useless until you actually turn it on. The no shutdown command is basically the power button. But at the same time, we do the opposite for any port we're not using. We issue a shutdown command. Why? Security. It stops someone from just plugging into a spare port and getting onto your network. Here's a really important dose of reality. Simulators like Packet Tracer are incredible for learning, but they are not perfect. And as the source points out, sometimes they can report things a little weirdly. It's just a great reminder that simulators are fantastic for practice, but nothing beats knowing the quirks of real physical hardware. All right, this next point is absolutely crucial. Everything we have done up to this point is temporary. It's only living in the device's active memory. If we were to pull the plug on this router right now, all that work would just vanish. We've got to save it. And this table really breaks down why. The running config is what's happening live, right now. But it's volatile. It's gone the second the power is cut. The startup config, on the other hand, is saved to permanent memory. It's what the device loads every single time it boots up. So our whole goal here is to copy what's running over to what's starting up. And guess what? There are a few ways to do it. These 3 commands all do the exact same thing. Copy running config, startup config is the modern, super clear way. Write memory is an older command, but you still see it everywhere. And write is just the shortest, quickest way to get it done. We're just using a different one on each device to show that they all work. And that's it. We did it. We took totally blank devices and we systematically gave them identities, addresses, and solid connections. We labeled our work, we secured the unused ports, and most importantly, we saved our configuration so it's permanent. We have officially built a working network. So we've successfully built our own little digital island, our own local network. It's up, it's running, it's stable. But what's next? The real magic of networking is connecting to other networks. So the big question is, how do we take this LAN that we've so carefully built and connect it to the rest of the world? Well, that's a whole other adventure.